Welcome to Easy Math TV. This is another video in our statistics series. We're going to be looking at some data here and determining, is there evidence to support the idea that there's a relationship between two variables in the data, two quantities. So what actually constitutes that evidence? So we're going to look at that in StatCrunch. And then once we are convinced that there is a linear relationship, then we're going to use regression to predict outcomes. So let's dive right in, okay? If so, we'll come back to this document in a moment to talk about like the meaning behind part B there. But the first thing we need to do is load our data into StatCrunch, and we're going to actually just show some plots. Let's look at part A, what constitutes evidence, okay? And then we'll come back to this to talk about what we do after that. All right, so I'm in StatCrunch. We're going to go to the data menu item, or the data menu, load, and then look for shared data sets, because these are not part of your book. These are data sets that I actually loaded in. And we're going to search by keyword. The keyword is possums. Possums. And just click on it, and that will open the data in StatCrunch for you. So we're looking at well over 100 possums here. There's like 104, I think. If we scroll all the way down, there's 104 possums represented in this data set. And they were measured. There were 4 measurements taken. So these are also a mix of male and female possums. We have them in a wide variety of ages. I'm not sure if these are months or years. I'm assuming they're years. So these are like ages and years. And then you have head length, skull width, total length, and tail length. And we're not going to look at all 4 of those numbers today. We're just going to look at 2 of them and to determine if there is, in fact, a linear or a correlation between those 2 things. So is there a correlation between head length and total length? So to answer that question, we have to go to the stat menu and look for regression, simple linear, and choose which variable is going to be our starting variable. So what is our predictor, or the input? That's going to be our head length. And then our output variable, or the response, is going to be the total length. And scroll down, because we've not learned about hypothesis testing yet. So scroll down and choose multiple graphs here. So to choose multiple graphs, you're going to hold down either the shift key, the command key, or the control key. One of those keys on your keyboard will allow you to select multiple things. The first thing we need is our scatter plot, which is the fitted line plot. And then I'm on a Mac, so I'm going to hold the command key down, and I'm going to choose 3 more plots. The QQ plot of residuals, the histogram of residuals, and residuals versus X. Okay? So there are 4 plots altogether that we are going to be making. The scatter plot, which is our fitted line plot, the histogram, the QQ, and residuals versus X. So make sure you have all 4 of those highlighted. Then go down to this next window here, and we need StatCrunch to calculate 2 things for us. We need it to calculate residuals and predicted values. Residuals and predicted values, because we're going to be using that to answer a question, a follow-up question about our data. Okay? So those are the only things you need to worry about. I'm also going to make my color scheme accessible. You don't have to do that if you don't want to, but I'm going to do that. So now I'm going to hit compute. Okay, so we're going to ignore this first screen, the first pop-up here for the moment, okay? this is your regression results. So the first thing we want to look at, though, is the evidence. Okay, so there's a reason I had you do those 4 plots. These consist of our evidence. Beyond just the correlation coefficient R value that you've learned about in class or in statistics, there's a correlation coefficient R value that you use to determine how strong the linear relationship is. But you cannot use that number if we don't have sufficient evidence that there is in fact a linear pattern. So we need to look at that here. All right. First, number 1 is our fitted plot or our scatter plot. Do we see the points following a steady upward trend or possibly a downward trend? So if the points are following a upward trend, in this case, that's what we have here. We see dots that are basically following an upward trend. Then that's your first clue. Okay, clue number 1, the dots form an upward trend. Clue number 2, the histogram of your residuals needs to be approximately normally distributed. We've learned that before, okay? But what I want you to take away from this is that the tallest of the rectangles needs to be right near 0 here. So the tallest rectangle in your histogram needs to be near 0, and then the rectangles need to be getting shorter the farther away from 0 you get, to the left and to the right. And it needs to be roughly symmetric. So you can't have more rectangles to the right of 0 than you have to the left of 0, for example. It needs to be roughly symmetric. So the symmetry around 0, right? So basically there should be the same number of rectangles to the left of 0 that we have to the right of 0. And the tallest need to be in the middle, and then they need to be getting shorter the further out away from the center you go. That is what we mean by approximately normally distributed. That's clue number 2. So we have that. Clue number 3, the QQ plot of residuals need to be following a line, following a straight line, basically a diagonal line. So if your QQ plot of residuals is following a straight line and not following a pattern like a curve, if these were following like a kind of a curvy shape, that would be bad. Then you cannot proceed with your linear regression, okay? These kind of bounce a little bit, but they do seem to be roughly following the straight line, so that's clue number 3. Clue number 4, your residual plot. So that this is a scatter plot of your residuals, okay? Not the x versus y. This is the residuals themselves. And this plot needs to be showing no pattern at all. There cannot be an upward trend. There can't be a downward trend. The residuals can't be like fan shaped or showing any kind of shape or pattern at all. It needs to be random. As long as these dots seem to be randomly dispersed, and this is a straight line, and this is approximately normal, and this is showing either an upward trend or a downward trend, those are the 4 clues. You need those things to be true before you can even talk about doing regression. Okay, so just really quick, let's go back to this screen. You've learned about the correlation coefficients. So if you're working on a homework problem and it wants to know the correlation coefficient for this data, you've got your correlation coefficient right there. It's 0.69. So that's neither really strong nor really weak. It's kind of right in the middle. A weak relationship would be something closer to 0, like 0.25 or 0.4. something really strong would be closer to 1, which would be like 0.9 or 0.95. That's a really strong relationship. So this is kind of wishy-washy there. The other number that you might be asked for is something called the p-value, and you can find that right here next to the slope. So the slope of our equation is 0.8336698. That's that red line that you saw. So like this red line has an equation, and the equation is y equals 9.888 plus 0.8336698 times x. That p-value there, as long as that's really, really small, like smaller than 0.05, then you have sufficient reason to move forward with this problem and we can now use it for prediction. Okay, so let's answer one more question about this situation. All right, so what do we have? We have our 4 plots that all gave us evidence, sufficient evidence to suggest that we could move forward. So if we decide that there is in fact a linear pattern, what is regression? Like, what do we mean by that? And the answer to that question is, this is the process by which we determine the equation of a line that best fits the data, okay? And the prediction line is given a symbol. Instead of just the variable y, we put a little caret symbol above it, so we call that y hat. So whenever you see a y with a caret symbol above it, it's referring to the y hat, which is the predicted value of y. So the predicted value of y for any value of x can actually be calculated, since we know what the slope and the y-intercept are, okay? Now, so is there a relationship between head length and total length? The answer is yes. We saw the 4 plots, and we see that the p-value is smaller than 0.0001, which allows us to say that there is in fact a linear relationship between head length and total length. So here's the question we're going to ask and answer. First, find the data value for a possum that has a head length 95.4 and 91.5. So let's go into our data and find that possum. And it happens to be right here in row 14. Notice this possum here has a head length of 95.4, which is the first number, and a total length of 91.5, which is the second number. And now you're going to see the reason why we include these other 2 columns, the residuals and the predicted values. Because in your homework, you're going to be asked a bunch of questions. So the first thing is, what is 95.4 measuring? And the answer to that is going to be, it is head length in centimeters. Head length in centimeters. And then what is the 91.5 measuring? And the answer to that question is that it's answering the total length. That is the total length of the possum in centimeters. That's its body length. For a possum with a head length of 95.4 centimeters, what is the predicted total length? So the predicted total length will be the number that is in column under predicted values. And you can see that's highlighted in pink there. That is 89.420332, but we're going to round it to 89.42. So we don't even need to use the equation for that. You can use the equation for that because you could actually plug 95.4 in for x, multiply by the slope, and add the y-intercept, and you get this 89.42 value. So the predicted value was 89.42. But the actual possum had a total length of 91.5. So the residual is the error between the model, which is our predicted value, and the actual value. So y minus y hat is 91.5 minus 89.42. But again, we don't have to get out a calculator for that because that was calculated for us in the residuals column. The residuals column has our residual, 2.079667, which I rounded to 2.08, okay? So we have our predicted value and our residual both for that particular possum with that value of x, the value of x that we were looking for. Okay, so that allows you to basically use, if you have the data, if you have access to the raw data in StatCrunch, you can perform the regression and you can insert those columns for the predicted value and the residuals so that you can actually use those for your homework questions instead of having to calculate them by hand, okay? Anyway, that's kind of an introduction to linear correlation between quantities and how to use them to make predictions. Like, subscribe, comment down below, share these videos with people if you think they might find them useful, and I'll see you in the next video.